Hi, this is Mr. Hodgen, and I'm doing the Algebra 1 first semester final review. Let's get started. The sum of 38 and m, the word sum means to add. Okay? So we want to add 38 to m. So let's start off with m, and then plus 38 would be the correct answer. Number 2, 35 less than a product of 4 and x. Okay, product means to multiply. So we're going to product of 4 and x. We're going to multiply those two together, which is the same as 4x. And we're going to take 35 less than that. So we'll start with 4x, and less than we're going to subtract 35. Okay, the reason why this isn't 35 minus 4x, just think of this. So what would the answer be if it was 35 less than 40? Right, 35 less than 40 would be 40 minus 35, which equals 5. So that's why we put 35 at the end and not the beginning. Number 3 and 4 are similar to 1 and 2. It's the backwards direction. So they're going to give us what the expression is, and they want us to write out the words. So there's no one right answer here. Since there's so many words for addition and exponents and to multiply, there's a lot of different words. So this is just going to be one particular correct answer. So we could say, how about number 3, 5 times x to the second power plus 2, or the product of 5 and a number squared and 2. That might be a good one. So let me just write it out. The product of 5 and a number squared plus 2. All right. Similar for number 4, we could say more simply, how about 9 times m to the 4th plus 7 times a number squared. Number squared. Again, these are just two possible correct answers, since there's so many different words for the different operations. Okay, number 5, let's go ahead and solve this. Rewrite it. So I got 2 times 2 times 2 to the second times 5 plus 8. So first we'll have to do multiplication. No, sorry. First we have to do exponents here. We can't simplify anything inside the parentheses. So first we're going to go to exponents. So 2 to the second is 4. And everything else is going to stay the same. I'm going to leave this in parentheses. So we're going to have times 2, we're going to have times 5, and we're going to have the plus 2 and the plus 8. So now we can do multiplication. So 2 times 4 times 5. Let's see here. 2 times 4 is 8. 8 times 5 is 40. Alright, and we'll bring down the plus 2 and the plus 8, and now do the addition. 2 plus 40 plus 8 equals 50. So we get A is the answer. Okay, number 6. Now we have 54 minus 3 times 8 minus 4. So let's start with parentheses. We have 8 minus 4, which equals 4. And then 3 times 4 is going to be 12. So we have 54 minus 12, and that equals 42. Alright, next let's evaluate, which means plug in. So we have 3c plus bc minus 2a. 3c means 3 times c. c is equal to 4. B is equal to 5. C again is equal to 4. And minus 2 times A, which equals 12. So here we'll get 12. Here we'll get 20, and here we'll get minus 24. So 12 plus 20 is 32. 32 minus 24 will be equal to, let's see here, 8. Yeah, those are both multiples of 8. Let's move on. More evaluating. Let's see, plug everything in correctly. So we have x squared, let's start off with that. 12 squared times y, that's 6, minus 2 times z, which is also 6, all divided by 4. So we have to evaluate this step correctly. Let's start off with the exponent, of course. So let's do 12 squared, 12 times 12, which is 144. Okay. And then we're going to have times 6, and I'm just going to go ahead and multiply this right here. So 6 times 2 is 12. That will divide by 4. And then we'll have to do 144 times 6. 144 times 6. We're going to get 864. Okay. And then we'll have to subtract 12 from that, which equals 852. And then finally divide that by 4, which equals 213. And this problem would just be a good exercise. You will not see numbers this large on the actual test. As long as you know what order to do the problem in, you should be fine. Let's see here. Next, number 9. We'll have 4 squared, which is 16, and then 16 minus 16 is going to be 0. So anything times 0 is going to be 0. So 7 times 0 is going to be 0. So really we have right now 11 plus 0 plus 7, which equals 18. Number 10. Let's see here. Inside the parentheses, looks like we have 10d minus 7d can be combined, but 8n won't because it's a different variable. So I can rewrite this as 4 times 8n, and then 10 minus 7 is 3. We have 3d. And we can go ahead and distribute as well. 4 times 8n is 32n, and 4 times negative 3d is negative 12d. Alright, our last one here, we'll distribute first. So we'll have 8 times 6x, 48x, and 8 times 2, which is 16. So we have 9x plus 48x plus 16. Alright, so the 9x and the 48x we can combine, which will equal 57x, and then the plus 16 will stay the same. Anytime they have the same variable and the same exponent, we can add or subtract them together. Let's go to number 12. Alright, so we have to look at this and first simplify whatever this is. So like on number 12, square root of 100 equals 10. And then number 13, negative 35 divided by 7 is negative 5. So we want to classify what 10 and what negative 5 belong to. So let's look at this, what this means. So we have lots of different types of numbers. We have the reals, which include rationals, right, which are fractions. So if it can be written as a fraction, that means it's rational, and almost any number can be written as a fraction. Even 10 can be written as 10 over 1. And we also have irrationals. Those are numbers that can't be written as a fraction, like square root of 2, and then another famous one would be pi. So most of our numbers we're going to be working with are going to be in this category, rational. And special types of rationals, well, if they're not any just random decimal, but just a nice whole number, positive, negative, then they're going to be an integer. Okay, so we have integers, okay, which are like -5 or 0 or in this case 10, and then you have whole numbers, which are kind of like the integers but just 0 and above. So whole numbers would be 0, 1, 2, 3, and so on. So for this particular problem, 10 would be considered a whole number and an integer and a rational number. -5 would not be considered a whole number because whole numbers start at 0 and go up, but it is an integer. So it's going to be an integer, a rational, and a real. Integer, rational, real. Oh, I see. Okay, so we got actually D for number 13. Integer, rational, real. Yeah, but for actually, yeah, number 12, it's also a whole number. Yeah, so 12 will say it's A. Let's see here. Okay, moving on. Go ahead and graph. Okay, so we have all the numbers. X is greater than -4.4, so that's all the numbers bigger than -4.4. So I'm going to do this simply just by putting -4.4 and knowing it's all the numbers bigger than that. So that's everything to the right. Notice I use the open circle because it's just greater than. If this is greater than or greater than or equal to, I'd bubble it in. Let's see here. Number 15. 4 times the number x increased by 15 is 83. Okay, so just as a translate. So 4 times the number x. Okay, so it's 4x. Increased by, which is the same as add, is means equals 83. It doesn't say to solve in here, so I'm going to say that's my answer, and that's it. Number 16. The difference of 5 times the cube of x and 2 times the square of x is 18. Alright, so 5 times the difference of, that's going to be subtraction. Okay, subtractive. So 5 times a cube means to the third power, and 2 times square means the second power is 18. So that should be answer A. And number 17. 4 less than the product of 8 and a number g. Okay, remember 4 less than. That means we're going to have to find out what the second part is and then subtract 4. So the product means to multiply. So then we're talking about the product of 8 and g and 4 less than that is equal to, that's equal sign, 10 more than g. So we're going to start at g and then go 10 more than that. Okay, go to number 18. Okay, so we'll have number 18, have to translate as well. So lots of ways of saying this correctly. I'm just going to pick one. How about 3 times the product of y plus 8 equals 32? So we can say, how about this? The product of 3 and y plus 8 is 32. That'd be one correct answer. Let's see here. We can go ahead and solve number 19, solve the equation, and check it. Okay. Let's rewrite it with the variable on the left. Some people like that. So we can say what minus 66 equals 119. That's the same equation. And we'll go ahead and add 66 to both sides. Okay, so we have n equals 9 plus 6 is 15, so we got to carry that 1. And we got 6, 7, and 8. And bring down the 1. So 185. So if we plug it back in, 185 minus 66 should equal 119. Number 20. What number minus a half will equal 3/5? Alright, so let's rewrite that over here. A, what number, minus 1/2 is the same as 3/5. So I'm going to add 1/2 to both sides. Here we're going to have to find some common denominators. So what's the smallest number that both 5 and 2 go into? Should come up with 10. Both 5 and 2 go into 10 evenly. We have to multiply by 2 here to get to 10, so I'm going to do that top and bottom. We got 6. And we have to multiply 2 by 5 on this one to get to 10, so top and bottom the same. So we get A equal to 6 plus 5 over 10, so 11 over 10. And don't see that answer over here, so let's convert it. Maybe it's this B. So 10 goes into 11 one time with a 1 of a remainder. So yeah, we do get answer B. Uh, 21. Some more practice with fractions. So add 2/5 to both sides. This time it's a little easier because there's already common denominators. So that's 0. So A will equal 1 plus 2 over 5, which is 3 over 5. Number 22, we can add 5.3 to both sides. Make sure you do your addition correctly here. Line up your decimals. So we get 9 with a 7, so H should equal 7.9. 23, what divided by 7 equals 3? So divided by 7 we can undo by multiplying both sides by 7, or 7 over 1. So we'll get B equals 3 times 7, which is 21. So 21 divided by 7 is 3. Number 24, a couple ways of doing this. We can cross multiply and divide, or if it's a nice even number, maybe we can just use some critical thinking. So can we multiply anything from here to get to here? So 9 times what will give you 90, right? So you can say multiply by 10. So if we do the same thing over here, multiply by 10, we'll end up with 70. You can also do another thing where we cross multiply and divide. Maybe you don't get a nice even number, we can always do this. This times this will equal this. So we multiply along the cross products. And then if you divide both sides by 9, you get x equals, see, 9 goes into 90 10 times, and 10 times 7 is 70. So either way you get the same answer. The second way works all the time. The first way would only work if you know exactly how to multiply from one number to another. Alright, here we go. Let's continue on. We have to do negative 448 equals 64 times what? So I know it's going to be 64 times a positive number, or a negative number, sorry. So I know it can't be this, because we have to get to negatives. At least I can eliminate one thing. And I know 64 times negative 512 isn't going to be correct. So our answer is either going to be 64 times negative 2 equals negative 448, or 64 times negative 7 is 448. So maybe just, with those two choices, you can probably guess that the answer is going to be D. But just to solve it, we'd go ahead and divide both sides by 64, and I'll let you guys do the long division to see, well, how many times does 64 go into negative 448? And my guess it'll come out to be 7, so that's why we have an answer of negative 7. 26 is very similar to 24. We have a proportion here. Let's solve it. This time let's just do the cross products again. So we got 9 times n, which will equal 54 times 4. Notice how I don't actually find out what 54 times 4 is. The reason for that is that it's a little bit hard to do division. So if I had 54 times 4 would be 216, then I have to find out what 216 divided by 9 is and have to do some extra work. This way I already know that 9 goes into 54 6 times. Right? So 6 times 4 will be our answer, which is 24. So a little less work. Alright, number 27. Go ahead and solve this. Subtract 7 on both sides. We'll get 2x equals 79 minus 7, which is 72. Divide both sides by 2. 72 divided by 2 is 36. Number 28. I'm going to start by adding 7 to both sides since it's minus 7, and then I'm going to multiply both sides by negative 7 since it's a divided by negative 7 here. So first add 7 and then multiply by negative 7. So if I add 7 to both sides, I'll have some number divided by negative 7 is equal to 12. What number divided by negative 7 equals 12? Let's multiply both sides by negative 7. We'll have a equals negative 84, which is B. 29. Find 3 consecutive integers with a sum of 48. Okay. So even integers, I'm just going to pick some random even integers that are consecutive. First of all, consecutive means in a row, like maybe 2, 4, and 6. Those are 3 consecutive even integers. If we add these up, it equals, let's see, 2 plus 4 is 6, 6 plus 6 is 12, that's not 48. So we know these are not the correct answers. But in general, let's see, if we wanted to say, well, we don't know what the first number is, so we'll call it x. We know that the second number is 2 more than the first number because even numbers count by 2's. So we could say, well, I don't know what it is, but I do know it's 2 more than the first number. And I don't know what the number is after that either, but even numbers, if they're consecutive, they go in order. So if this is 2 from the first number to the middle number, it's 2, and from the second number to the third number, it's 2. I know from second to first to the last number, it's going to be 4 more. So I know the third number is 4 more than the first number. So if I add up all of these, it will equal 48. Okay. And to solve this, we'll have 1x, 2x, 3x, plus 2 plus 4, which is plus 6, equals 48. Subtract 6 on both sides, so 38 is going to be equal to 42. Divide both sides by 3. 42 goes in there. 3 goes into 42, let's see, 14 times. So I know the first number is 14, the next even number is 16, the next even number is 18, and if you do check that, they do add up to 48. So we're good. If this said consecutive odd integers, we'd have the exact same equation because odd integers are also 2 apart. So remember that the plus 2 and the plus 4 are not because it's even, it's because that both even and odd numbers are 2 apart. If I did 1, 3, and 5, see these are also 2 apart, and the first to the third would also be 4 apart. So we'd still get the same expressions, whether it's even or odd. Okay, with number 30, let's find 3 consecutive this time. So let's say if it was like 1, 2, and 3, just consecutive. Our first one would be x. The next number, if we don't know it, will be the first number plus 1, because we do know from here to here it's 1 more. And from here to here, it's 1 more. So altogether it's 2 more. So our third number is 2 more than the first. Alright, that equals 39. So for even and odd, we'll have a plus 2 and a plus 4, but for just regular consecutive, will be plus 1, plus 2. And we can solve it the same way. We have 3x plus 1 plus 2, which is plus 3, Subtract 3 on both sides, get 36. Divide by 3 on both sides, get 12. So I know that 12 plus 13 plus 14 equals 39. And do make sure you know the equations. You're actually going to be tested on knowing this part, not necessarily the answers at the end, but you want to know the equations. Alright, so 31 through 34 just looks like some equation solving. So in general, you want to get the variables to the left and numbers to the right. So I'm going to add 17 here to both sides. Right? And I'm going to subtract 20 on both sides. Notice I'm doing the variables and the numbers at the same step. Okay, so that's 0, and that's 0. Variables on the left now, numbers on the right. So negative 7 plus 17 is 10, m. And negative 20 and negative 10 equal negative 30. So 10 times what equals negative 30. Divide both sides by 10. M equals negative 3. Right, number 32. Go ahead and solve this several ways. We have common denominators, so it might just be easy to do the same steps. Let's get the variables on the left, numbers on the right. So I'm going to subtract 2/5 k on both sides. Then I'm going to add 5 on both sides. 4/5 minus 2/5 equals 2/5. 4 minus 2 is 2. So we have 2/5 k, that's 0. Negative 7 plus 5, that equals 2. And this part equals 0 as well. Now to finish this, we're going to multiply by this reciprocal on both sides. If you need to, you can make this a 2/1 if that helps. Okay. So that equals 1. 5/2 times 2/5 equals 1. And 2 times 5 is 10. 1 times 2 is 2. And 10 divided by 2 equals 5. So k equals 5. Number 33. Alright, let's go ahead and solve this. Variables to the left. So let's subtract 8x. Subtract 8x. Numbers to the right. Add 26. Add 26 and I'll put 0.0. Keep the decimals lined up. Negative 58 and negative 8 would be negative 64x. Okay, this is 0. This is 0. Alright, negative 230.6 plus 26 is going to be negative 204.6. Okay. And you don't really have to worry about having a problem with this kind of decimal on it on the actual final, but just note the steps for solving it. But if we were to solve it, we would get x equals 3.1. And that would be positive because a negative over negative is positive. Alright, here we go. Let's do number 34. Gotta do a little distributor property first. So 4 minus 3 times 3 over 5 would be 9/5a. And 3 times 4 over 5 would be minus 12/5 equals 7. So notice how I just multiplied by the top number. If you need to, you can say this is 3/1 and 4/1 to help you out. So on the same side here, we have 4 minus 12/5. So we want to subtract those and find out what that equals. 4 minus 12/5. Go off to the side. See, 4 is the same as 20 divided by 5. And why did I choose 20 divided by 5? Because the denominator is 5. So I got to figure, well, What divided by 5 will give me 4? And that's 20. So I have 20 minus 12, which is 8 over 5. So I got 8 over 5 here. Negative 9 over 5 a, okay, plus 8 over 5 equals 7. To solve this, you need to subtract 8/5 on both sides. Subtract 8/5 on both sides. I'll make this 7 over 1. So 7 is the same as, let's see here, what divided by 5 would equal 7? So I think that's going to be 35 over 5 is going to equal 7. So 35 minus 8 is going to equal 27 over 5. Okay. So what I just did is a little arithmetic. I need to rewrite this part though. So I have, let's see here, let's go up here, we got some space. We have negative 9/5 a equals 27/5. It's nice that we both have the same common denominator, so I'll multiply by the reciprocal. 5 over negative 9, 5 over negative 9, that equals 1. We have 1a equals, let's see here, 5 and 5 cancel out. Negative 9 goes into 27, negative 3 times. We get a equals negative 3.